So we are going to go step by step, doing that basic things to understand what's going on. Okay. Okay. Cardiac cycle. Brief, then details later. Okay. Usually it starts with B wave. Why it is named B? Don't ask me, I know so. Okay. I don't know why not A, B, C, D. I don't know. Okay. So B wave represent what, as we agreed before? Atrial depolarization, which is going to be contraction. Is that all right? QRS complex represent what? Ventricular depolarization again. Okay. And from T or S, T represent what? Of the ventricles. And what is the atrial repolarization?
Not shown.
Why?
Hidden.
Yeah, it is actually B wave is already tiny in comparison with the complex. So what about the repolarization? Can you imagine the repolarization of the ventricle in comparison to the depolarization? It is very minor. So what about that? So it is actually obscured in the complex, so cannot see it. Okay. Why there is a space between B and the QRS? Why we have small segment there?
Conduction.
What?
From
AV node what? Yeah.
SA to the AV.
SA node to AV node is already atrial depolarization. Going to the AV node. What happens there?
The filling, ventricular filling.
It actually gives a delay there. The conduction in the AV node is the slowest conduction in between other conductions in the heart. So it is slow down there, giving this pause over there, and where the heart block happens there. And why it is slow, allows the blood to flush to the ventricle before the contraction of the ventricle. Okay. Intervals, all other parameters are going to discuss isolated. Okay. Again, there's another view. Also, the B and the segment as well represents the atrial activity, and the complex and the T wave represents the ventricular activity. And this is how it goes. So starts in SA node, going through the atrium, and there also to the other atrium, then goes to the AV node, which it relies there for a while before going to the bundles to right or either left ventricles. Okay? Okay. To interpret any ECG, we need to go through all of these items to avoid missing any. So, rhythm, is it regular or not? The rate, how to calculate, voltage, axis, comment about B wave, about the PR interval, the complex, the ST segment, and the T wave. Finally, you get up with some diagnosis. Okay? Rhythm. So, we expect either regular or irregular, there's nothing in between, isn't it? So, if it is fixed, it means the complex or the QRS complex between each other, they are already in fixed rate. It means the R intervals are always the same. We call it regular one. But if there is any variation, we call it irregular one. Okay. So regularism, how it looks like. So here is the complex. We can just simply, practically, we get a plain paper, we put it over the ECG, and we mark on the complex, and we move that marks all over the ECG, same lead, supposed to be, and we check if it's really identically comes to each one, so that's fine, it's regular. If not, it is irregular. Usually, with normal rates or Brady, we sometimes get it by just visual look. But if it is tacky, sometimes difficult to assess. We need to assess by paper. Okay? It's an example of a regular one, which you have variation for R and R. So simply, it is irregular. Obviously, that interval is not equal to that interval. Do you need to have a paper? I don't need it. Isn't it? This is obvious one of irregularism. So initially you have to tell this irregular or not irregular. It might be slow, it might be more quick, but at the end we judge about the interval between the R and the R, isn't it? Here is another example. We can see it seems to be here equal, but big drop there. So you have to measure the R interval and check. Okay? Regarding irregularity, are there difference between irregularity and others? There is. How? Okay. Usually the heart pumps this way. Fixed interval, same intensity, everything. Okay. What about that? What's that? Irregularity. Any pattern there? No pattern. So it is irregularity. It is no pattern there. What about that?
Regular.
Yes, it is not regular because the intervals are different, but there is regularity in the irregularity. It means there is a pattern going on. Have you got that? Okay. Here is an example of regularly irregular. So, to correct, pause, to correct, pause, to correct, pause. So it is in a regular way, irregularity going in a regular way. The best example of irregularity is, of course, no pattern. Here is narrow, wide, different, no pattern. Okay? So regarding the rhythm, we need to know that rhythm is regular or irregular. It is one point we have to discuss about when we interpret an ECG. Then rate. How we can calculate rate? Anybody knows?
300 divided by the RR.
Okay. The RR interval what?
Big square.
Big squares. Okay. So one way is to divide 300 by number of big squares between each R and the following R. It does apply to any ECG.
No, because if it's irregular, you got to.
Okay, in irregular one, you'll find different RR intervals. Can I use it? No. Do you have an alternative one?
Do it in 10. So you count how many square in 10.
10 what?
10 big squares.
Okay, then what you're going to do after? Okay,
Someone doing 10 though.
simple way. 10 seconds.
How many cures?
How can I get 10 seconds in ECG, baby?
From beginning to end. It's 10 seconds long.
Okay, let me make it easy for you. Do you remember when we discussed the basic, the boring lecture? Is it is important. It's boring, but it's important because it set up something there. You will recognize later. Do you remember when I told you the rate of the paper, printing paper is 25 millimeter, which is actually per second. It means 5 big square per second. Is that good information for us? Yes. So I can count some more seconds. Then I can multiply until 1 minute. I'll give you an example. 5 big square is 1 second. Is that right? It is the rate of the paper. Calculate other way. The tiny small square is 0.04 and the big square is 0.2 of a second. Then 5 big square is 1 second. The other way to calculate whatever you convince with. Okay? So 5 is 1 second. I need 6 seconds. So how many big square I can count? 30, yeah. 1 second, 5. So 6 seconds multiplied by 6, so 30. So 30 big squares actually represent 6 seconds. Then what I can do, I can just mark 30 big square. I can count the R number of R's inside the 30 big squares, and then what I can do, it represents the rate in 6 seconds.
5%.
So by 10, it gives you 1 minute. Simple as this. So count 30 big square, count the number of R's in between, multiply by 10, it gives you the rate. But actually we depend on the machine. Don't do that, practice it yourself. Practice it yourself, okay? Any other way to calculate rhythm? As you mentioned before, 300 divided by number of big squares in RR. To make it simple for you, is it usually to have the RR at the end and at the beginning of big squares? Is it always like that? So it's a bit difficult, isn't it? It is easy if I can adjust it in some leads, but sometimes it's not possible. It gave actually some tiny squares here, tiny square there, some big squares in between. It's happening. Any other way to calculate? Anyone knows? Okay, simple. Big square contains how many small square? 5. So the number here, the 300 over the number of big squares. So if I convert that big square to a smaller one, I have to multiply by 5. Down. Same way, I have to multiply by 5 over here. So 1500 divided by the small squares, the tiny one. It's the same way but more accurate. Usually if you have, for example, make it simple. Fractions like 4 over 5. If we multiply both of them in 5, what will happen? It will be 20 over 25. Is it same? Is the same? Because I have multiplied both of them in the same number. The same happening. I've done the same here. So 300 divided by big squares. Big square contains the 5 small, so I can multiply down by 5 and above the 300 by 5. It gives the same result, isn't it? But more accurate. So we have 3 ways to calculate the rate. 300 over the big squares between R and R. 1500 divided by small squares between R and R. And if it is irregular, we can count 30 big squares that are in between, multiply by 10. Can we use that method in the regular one? The 30 big square multiply by 10. Can we use it in the regular one?
Irregular.
In the regular one?
The regular one.
Yeah, can we use it? Absolutely. Why not? It can be done. But usually it takes time, that's why we make it easy by this way. But it can be, because same idea, isn't it? Okay. I need the rate here. Any suggestion?
60.
Sorry?
About 60. Oh no, is it regular?
It is regular. It is the same ECG anyway, the machine one. Okay? It is regular. So if we come to here, to there, okay, I will assume that that big arrow is here and that big complex is on the end of the square. So how many squares here?
4.
4. So what is it?
75.
Okay, it is a bit smaller than I expect. So might be 70. Do you need it more accurate? Yes, okay. 1500 by small squares. You can do it. Is it alright? Okay. Okay. What is our normal value for the heart rate? 290. Yeah, more than 90. We assume it is going to be more than normal, than over 100 obviously. Yeah. So we'll give it up to 90. Okay. So how much is it here? Okay. Here is the complex, and here is the complex. Big squares are 1, 2, 3, 4, 5, 6 big squares, and 3 small squares here, 2 more small squares here, So it will be all 1, 2, 3, 4, 5, 6, and this and that will be 7 approximately, isn't it? So 300 by 7 equal to 40 plus. Okay, 40 plus, so it is bradycardia. Can you calculate more accurate? Yes. We just, again, 1500 divided by the all small squares. Then you can get more accurate reading about the rate. Okay? Someone to tell me the rate here. Who likes?
150.
Is it written somewhere?
No.
Okay. So calculate quick one. Okay. So I will choose a better one to be on. Okay. Whatever. I will use it. So one big square, and two small. How much you have?
I did 150.
150 usually, if it is on here and on there. So 300 by 2, it will be 150. But it's a bit bigger than. So something below. 3 big square is 100. 300 by 3 is 100. So it is somewhere between 100 and 150. And it depends about how many small squares. So I can tell 120, 125. You need more accurate. Yes, 1500 by small squares. So 1, 2, 3, and here 5 is 8, and here 4 is 12. 1500 by 12. You divide 8, it will come out 20. I'm going to calculate. Okay. That's okay. So it is again tachycardia. Okay. That one, how much? It's an exercise.
1500 divided by 7.
Okay. Gives how much?
I don't know.
Okay, I mean, yeah.
A lot.
Me too. A
More
lot.
than it should be.
Okay, yeah, a lot. Okay. If we will assume that it is one big square, it will be 300. Two big squares, it is 150. Actually, the RR is between both of them. So it is initially, I can tell, it is between 150 and 300 approximately. So how much? So 1500 by 7, as you calculated, 7, is it that? Approximately 1500 by 7 or 8, it will come approximately, I believe, near 200, isn't it? 220, 210, yeah. 200 by 7 anyway is 1400.
240.
240, yeah. 200 it means 14, yeah. So it's 214 approximately. Okay. In irregular rhythm, I have explained earlier, with number of R's or B's, that's forget B. Number of R's in 30 minutes. Why I told B? I told you forget B. Do you remember heart blocks? Especially complete heart block. We find B waves are playing their role, it's their own, and QRS are playing their role, their own. So I need to calculate what is the atrial rate, what is the cardiac or the ventricular rate. So I calculate the number of R and B's separately. But in usual one, we calculate the R waves in 30 squared, then multiply by 10, it gives us approximately what is the rate. Okay? Is that regular one?
No.
Obviously no. So how we can calculate the rate here? We need to mark. Where do you like to start? Here? Why I choose that? Because one mark here I will not forget. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Here. How many R's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Okay? So 16 by 10 is
160.
approximately. If you choose another 30, it might give 15. So that's why I'm saying approximately. Because it is irregular. Okay? But if it is regular and I use that method, whatever I'm going to choose my squares is going to be fixed with the same. Okay? Good. At that stage, any question? No. Is that clear? You know how to assess if the rate is, if the rhythm is regular or not, and you have to, are you able to also calculate the rate in both cases, either regular or irregular? Is it okay? Any question at that stage? Okay. I believe. No, just a reminder, you know. Okay. Okay.